Hello and welcome to Data Pipelines with Firebase and Google Cloud. I am Alex Memring, and I have with me today Chris Rayner. The both of us are software engineers on Firebase hosting. We've built and we've rebuilt data pipelines based around Firebase. You may have seen ones to add your own domain to Firebase hosting using the custom domain provisioning system. We've also done live user-triggered data migrations from one backend to another. Our goal here today is to introduce you to some concepts and best practices that we've had to learn the hard way.
So, what is a data pipeline? Well, for the purpose of this talk, we're going to call a data pipeline a body of work to be done, not on the client specifically, and often as a result of changes by a client. We use some examples to illustrate some of the reasons why you might require a data pipeline, the first of which is trusted code. So this is the kind of code that you don't want to run on clients. The examples of this include uploading game state or running financial transactions. Imagine every user of a game allowed to upload their own score and how quickly that would devolve into chaos. Second, we have business logic. This is code you might not want to run on your client because it's your secret source. You want to protect it. You don't want other people to be able to use it, to find it. It might be a recommendation engine or something else that you want to change quickly and not wait for all of your clients to update, or all of your users to update their clients. The third example is aggregation of data. This is perhaps data from many different clients that you don't want to make available to lots of different, or every client. This might be things like average financial transaction amounts or operational metrics. And finally, you have complex or asynchronous tasks. And these are tasks that might need specialist software or specialist hardware to run, or they might be too time-consuming or battery-intensive. Things like video transcoding or image thumbnailing come to mind. With that, I'll hand back to Alex to talk about the basis of our examples, AppShip 3000.
You may have seen the AppShip 3000 game out by the Firebase sandbox right over there. This is going to be the example that we're going to use for all of our data pipelines that we have. It's going to be the overarching one that we've implemented all of these into the game. For those of you who may not have played the game yet, I'm going to give a very brief introduction of it. The very first thing that you do is you sign into the companion mobile web app. This allows us to associate the score that you get in the game with your actual user profile. We give you the arcade sign-in code that we've generated from your login to then be able to log into the arcade controls that we have at the game. Next, you work with the two other players that are playing the game with you cooperatively to try to steer the ship and avoid asteroids. Two of the three of you have to agree on which direction that you want to go before the ship actually moves. You lose fuel slowly over time as you climb, but you can regain this fuel by answering various trivia questions about Firebase, Android, and Google in general. However, the question may not actually appear to you. It may appear to one of the players next to you, and you may not have all the answers. So you have to shout out the question and what answers you have so that the three of you can communicate and pick out which one's the best one.
So our first example data pipeline in this game that we're going to talk about today is trusted code. Now, in our example, we wanted to write a score supervisor that takes the historical game after it's completed, that's uploaded to the real-time database, and to verify that it is indeed possible. Now, with this example, this is very appropriate for a single cloud function. And so we take a trigger from a real-time database, we write a cloud function, and then when that's finished, we write back to the real-time database. Here you can see an action. So the first game here that's uploaded is verified as possible. As you can see, it's got a score of 1250. Whereas the second game has got a score of 1,000,000, and I don't know if you've played it, but that's not possible. To do this, we write a fairly short cloud function. We start with a basic database trigger. Here, we're listening to the type subnode of the real-time of the game subnode in the real-time database. We verify that it is indeed a historical upload. And then we fetch the entire game state. In this case, I'm using the admin ref, which is an initialized database reference to the location that triggered the database trigger. And I'm returning a function so that the cloud function here, I'm returning a promise so that the cloud function here knows to wait for its completion. This is where I then do the actual secret sauce of checking whether the game's valid. And if it's not, I simply I chain a promise and mark the game as impossible. If it is, I take the parent reference from before and I do a deep update, again chaining promises, of the type to verified and the score as the reported score.
One of the other things that we wanted to add was an all-time leaderboard of the highest scoring games across IO. So this could be as simple as checking to see if the score actually made it on there, or it could be very complicated. The very first iteration that we did, we just added the games into this 10-game list. But we shortly found out through our testing that one particular team occupied like the first 5 slots, which is not at all what we wanted to have happen. So then we started enforcing that a team could only have 1 spot on the leaderboard at a time. So let's dive into a little bit of the code here. You can see that this starts out very similarly to the example Chris just gave. We're also triggering on a game right when it gets added. However, instead of triggering on a lower path down, we want the entire game object. Next, we check to see if the game score is verified by Chris's function earlier. If not, we just short circuit right there and in the function. Following that, we actually have to go grab the all-time leaderboard so that we know what games were played before, and we can compare those. We use the admin SDK here to get a privileged access to the database path. We instantiate this earlier on in the code, as you can see here, using the Firebase admin SDK. To have this privileged access, you have to use certain API keys and service accounts. Luckily, since you're deploying these functions in your project already, it knows your default credentials and can supply those for you so you don't have to paste in the giant JSON object. Going back to our function, the next step is we actually insert the game in the appropriate location or replace the team's already existing game on the leaderboard with this new updated high score. Then we set the all-time leaderboard back at the same path that we got it from. Finally, we notify the team that got bumped off of the leaderboard with a push notification. Looking more specifically at that, we have to use the admin messaging API to actually send this message to them using the FCM tokens that we gathered when they signed into our mobile web app. The important part to note here is that this requires the API keys and the service accounts that we talked about before, because you wouldn't want to give any end users this privilege to just spam the rest of your end users with push notifications at any point. So, extending this example a little bit further, we also wanted to have a more recent leaderboard. So only the games in the past hour would be shown on this one. You can still do this example using just the Firebase real-time database and functions, but it begins to get more complicated. You have to end up structuring your data in tricky ways, and you have to make sure that you write your queries correctly. Instead, what we're going to do is we're going to lean on Cloud Dataflow to help us deal with aggregating all of these various games that are coming in at random times. So, the first step here is that we're going to still trigger on the real-time database when a game gets added, but now in our cloud function, we're going to be sending a pub sub notification. Chris is going to talk more in depth about Cloud Pub Sub later. For right now, all that we care about is that this is our communication layer with Dataflow. So very similar to what we wrote before. We're still looking at the games ref from the real-time database, but now we're dealing with PubSub. Looking more specifically at the new code that we have here, we have to use the Google Cloud PubSub Node.js module and instantiate that. This also needs certain credentials that you have from your project, but again, since Cloud Functions is being run under your project, it already knows your default credentials, so we can just instantiate that right away. Next, we have to have the PubSub topic, and we are going to push the entire game object to that. From there, Cloud Dataflow is going to be listening to this PubSub topic, and every time we get a message in there, it is going to fully process this. Dataflow is the cloud product that helps you with doing batch and stream processing over large amounts of data or lots of different inputs. It allows you to do fully managed resourcing that scales on demand so that you don't have to worry about dealing with any of other machines or boxes and turning those up when needed. The nice thing about this is that we're going to be getting a fairly random stream of games being played because we don't know how long each one's going to be taking. But coming out of Dataflow, we're going to be sending a very periodic update every 5 minutes with the new updated leaderboard. So let's look at the Cloud Dataflow code. This is written in Java, and basically each one of these apply steps is just going to be a transformation from one type of data into a slightly different type of data where we've changed things around a little bit. At the very first step, we're just listening to the PubSub topic that we just wrote to. Every message is going to come in through this, and then we're going to be using Jackson to change the JSON message that's part of this PubSub notification into a plain old Java object. From there, we're going to be using a class that I wrote myself, the setKeyAndTimestamp class. And that is just basically going to be saying, hey, we only really care about the team, each user's name that's on that team. That's how we're going to uniquely identify that game. And then we're going to set the timestamp to be when the game ended and got added to the real-time database. At that point, we're going to be using a sliding window of 1 hour. So we only care about the data that came in the past hour, and we're going to throw away everything else. And then it's going to send out all of that data every 5 minutes, and it's going to process through the rest of our pipeline. Then we're going to deal with actually finding what the maximum score for that team was in that past hour. If they played 5 games, we really only care about the one game where they got their best score. Then we select the top 10 of those users or those games out of that big long list that we have. That without defaults there at the end, that is just saying that we're fine if we didn't have any games played in that hour, just give us an empty list at that point. And finally, we take that list of data that we just got and we use Jackson again to parse it back into JSON and send it back in a PubSub message. At that point, we're going to be just sending that back off to a different topic. So looking back at all of this, each individual line of code we have here is an individual class, has an easy-to-test function, and all of this is easy to compose. The nice part about this is we added a third leaderboard, and we were able to reuse most of that code. So we just wrote to a Cloud PubSub topic. We're now going to listen to that same topic using Cloud Functions, and we're going to write back to the real-time database so that that leaderboard gets updated, and you can see that on your mobile web app. So this final function here is going to look like this. A little bit different since we're now listening to a PubSub topic. This is the exact same topic that we published in Dataflow, and this will be triggered on every message that we get. And then we're going to just be writing back to this leaderboard using the same admin database reference that we had from before. So as an overview, this is all the steps that we took. Notice how it's mirrored right around Dataflow, and we end up just popping right back up the stack. Remember that coming in from the real-time database is going to be like a fairly random stream of events of games getting added. And then coming back out, we're going to be having a very periodic 5-minute update of the leaderboard.
So our final example of a complex task in this case is generating a flight image from the game logs. We create an image like this one that we send out a push notification to promote re-engagement with the app and sharing. Now, just like Alex's last example, this is perhaps too big to fit in a single cloud function. So we use a dedicated messaging system. In this example, we'll use Cloud PubSub as that messaging system, just like Alex did earlier. And in my code, I wrote some Go containers running on Container Engine here. With PubSub, the topic is the main input for messages. And each topic can have a group of subscriptions, any number of subscriptions. A subscription can be seen of as a queue of messages, and it's distributed between the workers listening on the same topic. In our case, we're going to use a single shared subscription between all our workers so that PubSub does the work of distributing that work for us. With this model, you can see that you can chain many of these tasks together. So you could have a topic for a set of workers, but then push onto another topic in an arbitrary amount. So, just like before, we have a trigger from the real-time database. We write a cloud function to bridge the gap onto our messaging system. And so we write the code. Again, like Alex did earlier, we start with a PubSub topic defined from the Google Cloud SDK. We have a database reference, this time linked to the score verified subnode of a game, so that only games verified from the first example trigger this. We do a final check to make sure that we're adding a new node and not removing it. And then we push this onto PubSub. One alternative to the way we did it here is if Alex and I shared a single topic, and then we defined 2 separate subscriptions, each of those acting as a separate queue of messages distributed between the two. In one case, Dataflow, and in the other, Container Engine. So once the Container Engine code, the Go code, renders the image, it uploads it to cloud storage. Now, in this case, we chose a bucket that we had associated previously with Firebase to make it super easy to write a cloud function to then send the push notification. We do this with this function here. We start this time with a storage onChange event. This is changed anytime any file in the storage bucket changes. We check to make sure this is a new file, the file that exists. And then we try to extract the game ID from the object name, returning if it doesn't exist. Now, at this point, we fetch the FCM tokens that our PWA has been storing in the database directly. This is, again, an asynchronous operation, so we use a promise here. And then finally, we send the notifications, just like Alex did earlier. So, as an overview, we used the real-time database to trigger a cloud function. that then pushed a message onto our messaging system. We use PubSub to then distribute work between our containers, which then upload to cloud storage. And finally, we trigger a cloud function on that storage bucket to send the push notifications.
Okay. As an overview, we started with the score supervisor, and we saw from there we can't necessarily trust what our clients are sending to us to be valid data. So we have to check that, and we have to be able to verify that on our own trusted machine. Next, in the AllTime Leaderboard, we really need to have an environment where we can change the code quickly. If we were using an Android or iOS app, we would have to push out an update and then wait for all of the end users to update their app before a change could go through. Using Cloud Functions, we were able to push that update right away and see that reflected. Next, with the hourly leaderboard, we had to deal with data that was coming in at completely different times, and we had to aggregate across that and many other sources of data. So we leaned on Cloud Dataflow to help simplify some of that complexity. Finally, with the flight path image, we began doing processing that was much more complicated. We need more control over the CPU and the memory, and we needed our own boxes to deal with this. So to help distribute this work across these machines, we used Cloud PubSub to more easily and manage the parallelism and the serialization that we need across all of these different tasks. So, thank you everyone for coming and listening. Chris and I will be right over outside to answer questions right after this. I hope everyone enjoyed I/O 2017.